Hello everybody. Today I want to try to make my first PCB ever. I'm interested in recreating this TB6612 FNG, so I want to keep it simple and just basically clone this little chip, motor driver, and then get it printed by some sort of PCB manufacturing service. I don't know, JLC PCB or something like that. I looked around already, watched some YouTube videos on the subject, and I see a lot of people suggest KiCAD. It's free and seems easy to use. So for now, I'll be following this tutorial from Math Code Print channel, how to create a basic KiCAD traffic light. I'll make that first, and then using this knowledge, hopefully I'll be able to clone my motor driver so I can learn how to make my first PCB myself. Alright, so following that tutorial was not too difficult. I managed to quite easily get what's going on screen, so I can recommend the tutorial. And now to the next stage, trying to design my first own PCB. So let's look at the schematics of the motor driver and try to reverse engineer them.
Well, I'm happy on my own, making coffee just for one, and eating breakfast all alone. Fewer dishes to be done. I'm never running behind. You're never on my mind. No longer there to make me comb my hair, fix my tie, or kiss me goodbye. Swear I'm happy on my own.
Okay, so yesterday evening I spent the whole evening trying to look at the schematics from Toshiba of the TB6612 FNG, and I was trying to rebuild rebuild the typical application diagram. So I'm not great at all of this. I wasn't very good in physics class, but I studied programming and I know a little bit about schematics, so I'm learning right now. I've been watching YouTube videos for the past 2 days about building schematics, setting the vias correctly, the ground pins and so on, trying to refresh my knowledge on capacitors, resistors, MOSFETs, all of that. And then I try to copy this typical application diagram. Something interesting I noticed is that I think they usually use one polarized capacitor. I decided, since in the Toshiba typical application diagram they show 2 capacitors to decouple the 12 volts and 2 capacitors to decouple the 3 volts, I decided I'll just try to do it exactly the way they suggest. So 2 capacitors, as you can see over here. I have the 100 nanofarad capacitor and then the 10 microfarad, I believe. And then I added the 100 nanofarad and the 10 nanofarad from the other side. They both connect to ground as they do here in the diagram. I looked it up and this is chassis ground, so I'm not sure if that's different from the usual ground, but I think this just connects to the usual ground. I labeled it common ground and 12 volt ground. Next, I created this PCB over here. I really know it's not beautiful, but I tried to do my best.
Where did it run to?
Okay, it's been almost a month. I finally got my package from JLC PCB, and now I can tell you about the experience I've had in the last month creating new PCBs, what my mistake was with this PCB, and how I would actually now create this motor driver quickly in KiCAD.
Oh, waiting for me to come home. Staying up till 3 a.m.
So, first I want to talk about the mistake I made. The issue is I shorted the ground over here. So under these two little capacitors, I shorted the ground. Other than that, the board works perfectly fine. So I'm pretty proud of my first board, but it doesn't work without a little fix.
I'm always out on the town. You're nowhere.
So all I had to do was take a knife and cut the ground, cut the short here. And after doing all that and wiring up my new motor driver, I can give it a little test run. Turn the motor on and turn the motor off. Again, the motor, turn it on, turn it off. So as you can see with a little fix, my motor driver works.
She gives me loving like I ain't ever had. And toss me to the curb like a dirty dish rag. Say, boys, it's a juice worth the squeeze. And every night she makes me feel like a king. Then treats me like a dog the very next morning. Tell me, boys, what you think? Is the juice worth the squeeze? Every time I see her, I tell myself I'm through. But I got this itch.
So this is what I would change about my original motor driver design. First of all, I would make the VCC much thicker. I'm using polygons for this. In this case, I used vias to route it. I would prefer not to do that. I would prefer to have the VCC somewhere here, but for now this works. Then the voltage from the motor comes in here, also with polygons, much thicker. Could also make it even thicker if I wanted to. Anyways, aside from this, I added the capacitors as close as possible to the IC. I made these lines going to the ESP or whatever microcontroller as short as possible, and I used polygons to connect the motors so that they are not limited from thin routes with power. And in addition to all of this, I made my name or logo in solder mask, so I added it on the copper pour and added the solder mask so it doesn't get printed on. And you can see if it would have an enic finish, it would be basically my text in golden. Yeah, that's what I would improve with 1 month of learning how to use KiCAD and make PCBs. If you guys have any suggestions what I could change, let me know, but I'm pretty confident this design would work quite well.
I'm always out on the town. You're nowhere.
So my first recommendation for beginners is use plugins. I'm using the JLC PCB KiCAD library plugin, which gives me a nice base of parts and symbols to work with, so I don't have to download every single part and symbol. For example, if I if I go in here and I type in 100K, then you can see these are the parts from the plugin, and they're directly on JLC PCB. You can look at the data sheet. They usually have a 3D model that comes with them, so on. So this works really well. I don't have to look for every single part. The second plugin I recommend is the JLC Fabrication Toolkit if you're looking to fabricate with JLC PCB, because that makes bringing your file to JLC PCB super easy. All I need to do is press the button once my fabrication toolkit is installed, and that will generate me the file, the BOM, and the positions automatically, which is everything I need to order it at JLC PCB. I can quickly show you how that would work. So I just pull the Gerber, the zip file in here. That will load. It should automatically set these layer settings. There you go. Then I can, if I want Anic finish, select that to get this in gold. You see the price just went up quite a bit. Next, if I wanted assembly, I could select assembly. And then next, I need to sign in. Now, this would be my PCB. By the way, make sure you don't put text over silk screen. Here the text is cut off. That's not nice. Something I wouldn't want for a final PCB. And here I just drag in the bill of materials and the positions. Processes them, tells me all the parts are in stock. You have to make sure that each part, if you double click it, if you double click the part, has an LCSC. So if you go to JLC PCB /parts, you can type that LCSC. This is the part I would be buying. Here's the price. You can see if it's in stock. You can research any parts here, and then you just need to bring the footprint in here. I'll show you in a second more. Let's finish. So here you can see these are the parts. They're all in stock. I would press next. It would show me the component placement, which in this case is slightly misaligned. So I would have to rotate this and rotate this. Now it looks aligned, making sure this is the positive, this is the negative. That is correct. So everything here is correct. Now I could go next and order. There you go. So yeah, this plugin has really helped me export everything. It makes it very easy for me. And then the last plugin I recommend is the Easy EDA to KiCAD from GitHub. It's quite easy to install. I'm not going to go through it right now. But basically, if there's any part I can't find in here, say I need a very specific part, I could go find it now here in JLC PCB. So popular products, let's say this part, you guys can see it has a footprint, but this part might not exist inside my schematics. There you go, it doesn't exist. Maybe I want to use this part and I don't want to create my own footprint, even though creating your own footprint is relatively easy as well. I can just take this LCSC number, and with Easy EDA to KiCAD, I can just go in my terminal. In my case, I just type in LCSC and then paste LCSC, and that will download it and add it to this folder. So now I can go in here, and there we go. There it is. The part is already directly there. I can go in here and bring in the part. There it is. And if it's missing the model, usually you can also find the model in here. Alright, I don't feel like looking for it right now, but usually you can also find the model in here. That's it. These are the 3 plugins I recommend if you're working with JLC PCB. And using all of this information and everything I learned in the last month, I try to build myself an ESP32, which should be over here, the ESP32 room, with, well, a button, obviously, and then a USB-C PD, which can switch between 5, 15, and 12 volts for my 2 motor drivers, which are all on board. And along with that, I have a buck converter. And along with this, the board is able to measure the power going to the motors with an INA 219. But my own ESP32 is for another project for another day. For now, I want to thank you guys for watching my journey in my first month learning how to make PCBs. If you guys have any suggestions what I can do better, or what helped you guys learn, or maybe I just inspired you to learn it for yourself, Leave some comments below, let me know what you thought about this video, and thank you for watching. Have a nice day, guys!